So this is in class example 5 for EGR 343. For this one, we have this beam that's in a triangular cross section or has a triangular cross section. The moment is 50 kilonewton times meters. It gives us some of the dimensions. It's basically 300 millimeters is the base, and that's 300 millimeters high. It shows where the moment is here. And then we're supposed to sketch the bending stress distribution over the beam's cross section. So let's get started. Um, so we could figure out to some degree what the cross section would be. The first thing to remember, so this is a triangle cross section or triangular cross section, um, and we know where that neutral axis is going to be. Um, it's basically going to be 1/3 from the heavier part. So this would be 1/3 of the 300 millimeters. So it'd equal 100 millimeters. And we could even draw the cross section. Um, so here's our triangular beam. Um, and on here, we know that neutral axis is along here. Um, and then we know that it's going to be bending up. So the top part's going to be in compression. And so up at the top is where we're going to have the maximum stress. That's compressive stress. And then as we get to the other side, it's going to be in tension. So we have compressive stress and then tension. But what we don't know what the stress is going to be, like what the value is at the top and what the value is going to be at the bottom. But we can find that. So to find that stress max, which would be up here at the top, um, the formula for stress max equals MC over I. They give us the moment. We know what C is. It's going to be that 200 millimeters. And then I, we can also calculate its I of a triangle is going to be 136 times the base, which is 300 millimeters, times the height, which is 300 millimeters cubed. So I'll calculate that really quickly. So we get 225 and then 1, 2, 3, 4, 5, 6 zeros. Um, and that would be millimeters to the fourth. So now we can take this equation. So stress max is going to equal M, which is that 50 kilonewton meters, so 50,000 newton meters. And then I want to change those meters to millimeters. So 1 meter is 1,000 millimeters. Those meters cancel out. And then times C, and C is going to be that 200 millimeters. And then divided by that I. So 225 million. I have millimeters squared on the top. And so that leaves us millimeters squared on the bottom. So newtons per millimeter squared, which would be megapascals. And so we get 44.4 megapascals. So that gives us that stress max up here is 44.4. megapascals. And then we also need to know this one here. So the stress at the bottom, which is that tensile stress. We'll just call it stress tensile max. That's going to equal my over I. And I is going to be the same. The Y is just that only the 100 millimeters are here. And the moment is also the same. So 50,000, actually, that's not gonna be enough room for me. So it's basically similar, 50,000 Newton meters times 1,000 millimeters per meter times Y, which is that 100 millimeters, divided by that 225 million. Check the units really quick. We get millimeters squared on the bottom. So we get newtons per millimeter squared, which would be megapascals. And basically it's just going to be this, it's almost the same formula. This one's just a half of that, but it's going to come out to 22.2 megapascals. So down at the bottom here, this one will be 22.2 megapascals. So that's all they asked for there.